Hello and welcome to video lecture number 5 of the ISE 215 Foundations of Design and 3D Modeling for Engineers course at North Carolina State University. My name is Jacob Peliquin, and today we're going to be talking about parametric and freeform modeling as well as configurations in Fusion. In today's video lecture, we're going to be looking at what is parametric design, evaluating design intent and incorporating that into our modeling, what are configurations, what are forms, and finally a freeform modeling walkthrough. The learning outcomes for this video lecture are to explain the principles of parametric design, configurations, and freeform modeling in CAD, specifically Fusion, apply parameters and equations to create models that reflect clear design intent, create configured dimensions and features to quickly allow multiple versions of a design, and to construct freeform models using forms, reference images, and editing tools in Fusion 360. So what is parametric design? Parametric design is a method for parameter-based design in computer-aided design in CAD, and it allows you to add or modify parameters at any point that are sort of these global parameters that can be used to define relationships relative to other dimensions and parameters. And so what I mean by that is we have an example here on the right where we have ring sizes. The size of the ring is a number 3 through 13.5, and this is just kind of a standardized size assigned to the ring. Whereas the actual diameter, the measured diameter of the ring, is listed below it, and you can see that it's not really a clear relationship here. So what you can use parameter-based design for in Fusion here is if you want to input the ring size into your design, you can automatically calculate what the diameter would be in terms of this standardized way of representing ring sizes, and then use that diameter in the dimension that creates this ring sketch. And so this is useful for creating these function-driven relationships and also for tracking and organizing parameters throughout a design. And you'll often see this if you have designs that scale. So if you have sort of a small, medium, large design, you might change some base dimension and that will scale the rest of the designs. For example, like a t-shirt, if you change the width of the t-shirt from a small to a large dimension, then you might also be changing the sleeve size and the neck opening size as well. So in Fusion, to access the parametric design window, specifically this parameter window here, you go to the top near your modeling tools in the Modify dropdown and select Change Parameters. In the Change Parameters window, you can specify, manage, and modify parameters and equations, and you can update these at any time. So here, we'll go through an example in a second, but here we have 3 user parameters that we've set for a simple box. One is the length, one is the width, and one is the height. And you can see that the height is actually a function of the length. And so we'll look at how that affects the design here in a second. So here's our parametric design example for a simple box. I'm going to go into Fusion now, and we're going to create this box with these parameters and the function-driven relationships we have here. So here I am in Fusion. I'm first going to save this file. I'll call it box. And a lot of times in Fusion, you have to save the file before you have access to certain features. Okay, so since I know that I'm going to be using these user parameters here, I'm going to go ahead and create them to start with. You can go back and edit these anytime, but if you already know them from the start, you might as well create them. So I'm going to go to the Modify dropdown. Change Parameters is near the bottom. And you can see here I have so far no model parameters and no user parameters. If you create something in a model, for example, if you create a sketch and add a dimension, or create a 3D modeling feature where you extrude something, those dimensions are going to automatically be captured here. But if you want to specify something that you use throughout the design, you can create a user parameter. So I'm going to go to user parameter and press this add button. And this is going to create me a user parameter here. So looking at our example, we have length, width, and height. Length is 2 inches, width is 1 inch, and then height is going to be 0.5 times the length. So I'm going to create length first. Our dimension is in inches, and we have a value of 2 inches. You can also leave a comment. I'm not going to do that for right now, though. So we have our first user parameter here. I'm going to create another one called width, again in inches. This was 1 inch. And finally, we have 0.5 times the length for our expression of the height. And again, we need to specify that this is going to be in inches. Oops, not height. Length. Okay. Now that I have those parameters saved, I'm going to create a basic sketch on the top surface. I'm using the R quick command to select rectangle. I'm just going to draw the rectangle. And now, when I'm dimensioning this rectangle, instead of typing in values, I can type in these user parameters. So if I go to the dimension button by pressing D, remember this is the quick command for the dimension. I'm going to create, this is going to be my length. And so I can just type in length here, and you can see it pops up below as a user parameter, and press enter. You'll see when you press enter that it says fx, meaning that this is a function or a user parameter. And my document settings are in millimeters, so that's why you're seeing 50.8 here. This is representing 2 inches, but in my document settings, it's displaying things as millimeters. If you wanted to change that, obviously, you could go to your document settings in the drop-down and go to inches. Okay, then we're going to do the same thing for the width. Type in width. And now you can see both of these are function driven, and we can change these in our change parameters window. Before I do that, I'm going to make the extrusion for the height. So I'm going to go to extrude. Everything here is going to be the same. I'm going to do a distance, one-sided, start at the profile plane where I created the sketch. But for distance, I'm going to type in height. And from our user parameters, we specified that the height is 0.5 times the length. So if we have length as 2 inches, our height is going to be 1 inch. You can see that here. Okay, so now I have this box. And now instead of going in and changing the dimensions specifically in the sketch or in the modeling operation, I'm going to go back to my change parameters window. I'm going to see if I can move this so that you can see the part. There we go. Okay, so because these are relationship driven, specifically the height, if I change the length now, it will automatically update the height. So if I double this length to 4 and press enter, you can see that my height changed as well. And so my height dimension now is 2. If I were to change the width, I can change that here, but only the width is going to change because nothing else is a function of the width, or nothing else has a relationship to the width here. And so that was how to do a simple box. Next, we're going to look at that ring example. Okay, and in this ring example, if we look at the relationship between the ring size and the actual inside diameter of the ring, this is the equation that we're going to use. So you take the ring size, subtract 3, and this is in units of millimeters. You multiply by 0.8, and then you add 14 millimeters. So going back to Fusion, I've created this ring document here just to have it ready to go. You will see that if I go into the sketch of the ring, I have given this internal dimension a strict value of 14 millimeters and the thickness a value of 1.5 millimeters. And then the width of the ring, or the thickness of the ring, is 1 millimeter in either direction. I've also added a 0.5 millimeter fillet to each edge. Okay, so now that I have the ring created, I can go to my change parameters, and set up my equations here. If you look in the model parameters, you'll see that I have these drop downs. For my sketch, here you can see those values that I hard-coded in here. Extrude, so here's the extrude parameters. This D4 is going to be the draft angle. We didn't set a draft angle, but these are the modifiable parameters within the extrude operation. And same with the fillet here. Okay, so for user parameter, I'm going to create the ring size. This is going to be unitless because the ring size is a unitless feature, and we'll start with 3. So now I have my ring size parameter here. We're also then going to create the ring diameter. So this is going to be in millimeters, and my expression is going to be from the first slide, 14 plus ring size minus 3 multiplied by 0.8. And so looking at our chart for the ring size 3, 14 millimeters is the value. We can double check with another one of these. So let's do ring size 10, should be 19.8. It's not quite exact, but it's fairly close, 19.6. So the actual equation is slightly different, but it has some trailing values after the decimal. This is just a simplified version of it. Okay, so now that we have this, now what we can do is go to our sketch dimensions. This 14 millimeter diameter that I strictly added, so I said this is always 14. Now I'm going to change this and make this ring diameter. And so now it will update as I change the ring size. And so you can see on the left, if I change the different ring sizes, going from a 3, we have 14 for the diameter, 8, we have 18 for the diameter, and 13.5, 22.4. And these are fairly close to what's in this table here. So this is another example of how you can use these change parameters to scale a design and have relationships between dimensions. And this brings us back to design intent. We talked about this briefly in one of the earlier video lectures, but we want to make sure that when we're designing something, and particularly if we're making different sizes and scales, that the dimensions we give reflect the actual purpose of the design. So in this case here, we have 2 different ways of dimensioning. On the left side, we're dimensioning both of these hole locations from the left-hand side. On the right, we're dimensioning the hole location on the left from the left-hand side and from the right on the right-hand side. And so what happens with this design is if we are to scale the length of this bracket, we always want the hole on the right to be this far from the edge and the hole on the left to be this far from the edge. We don't necessarily care about the distance of the right-hand hole from the left side, even though we've dimensioned it here. And even though in this case, with this current length, these holes are in the same spot. If we go to a longer length of bracket, you can see on the left-hand version, the hole has not transferred, versus on the right hand, it has transferred. And next, we have configurations. These are similar to parameters and parametric design, though slightly different. So in parametric design, we were creating relationships between dimensions. So if we scale one dimension, it scales another dimension appropriately or accordingly. For configurations, we are allowing the user to create multiple variations of a part very quickly. And so this is useful if you have different size offerings. So what we do is we configure certain dimensions and features. So for this example here, we've configured the length and the width of the sketch, but not the height. So in all of these configurations, the height remains the same, but you can see down here in the configurations table, I've set up the length and width dimensions, which are D7 and D8, to be 5 millimeters for one configuration, 10 for the other, and 20 for the third. So it's important to note 2 things: that we configure specific dimensions and features. The non-configured dimensions, such as the height in this case, remain constant throughout all configurations, and changes to non-configured dimensions are represented across all configurations as well. So if I were to change the base height dimension of this cube, it would reflect across every one of these. All of these height dimensions would change, while the configure dimensions would remain the same. To access configurations in Fusion, you go to the Configure dropdown. There's two options in this dropdown. There's the Configure button and the Display Configuration table. They're also both just listed as icons before you go into the dropdown. And so you can use a configuration table to set up and map out and see all your configurations. You can also use the Configure button then to configure specific dimensions. So I'm going to walk through this in Fusion, but basically what we'll do is we'll create a simple box, and then we'll edit specific dimensions across the different configurations. When you're doing this and selecting the dimensions or features to configure, you'll notice that you're in this sort of configure workspace. And so you'll see this, there'll be a blue outline around your workspace and this configuration button at the top. And so this is going to prevent you from changing any dimensions that are not going to be configured. This only lets you select what dimensions you want to be configured dimensions. Okay, so I'm back in Fusion. I'm going to create a new box. This time is not going to be a parametrically designed box, but rather a box with different configurations. So I'll create a sketch on the top surface again, create another rectangle. I'll give these dimensions to start with, so I'll make this 5 millimeters and 5 as well. And then for our height, we're going to make that 10 millimeters. Okay, so we have our box. Now what we want to do is create configurations. So you can do this in two ways. I can press the display configuration table. You can see that I only have one configuration right now. I can add more configurations with this Add Configurations button. So now I have 3 configurations. However, there are no configured dimensions for these configurations. So if I want to change dimensions across these configurations, I can do that one of 2 ways. I can click on the Configure button at the top. And so this is going to bring up this blue outline and this configuration mode signifier up here. The second way to do that is inside the configuration table, you can click on Add Aspects, and it will bring up the same window. If you want to access your parameters and your parametric design from the configuration table, you can do that with this button here. Okay, so I'm going to add configurable dimensions. I click on Add Aspects, and now you'll see at the bottom my sketch and my extrusion here are highlighted. If I click on these, it'll give me all of the configurable dimensions and features from either the sketch or from the extrusion operation. So for the sketch, if I click on this, I have 2 linear dimensions, and if you hover over them, they'll highlight and be shown on the model. So I want both of these to be configurable. And just to show you how to do it, if you go to the Extrude button, you're given other features here. So I could do the distance of the extrude, I could change the taper angle across dimensions, and I could suppress this feature across dimensions, meaning that only some configurations would actually have this extrude. So I'm going to select distance. Okay, and now we have our configuration table. So now I can change things on the side here. Let's say for the first one, let's say for all of them, I want the height to be 10 inches. Maybe for the second configuration, I want 10 inches to be the length and the width, and 20 for configuration 3. To view your different configurations in the model window here, once you've created these configurations, you'll have a drop-down, and I can cycle between them by clicking on this drop-down in the design tree and selecting the configuration that I want. When you're done configuring dimensions, and let's say I want to add something else, I can end configuration mode. And perhaps at this stage you want to continue with your design. I'm going to quickly just create a sketch on this top surface. Let's say it's a circle with a dimension of 3 millimeters, 3 inches. And we want that extruded to an arbitrary height, 10 inches. Now what you'll see is that as I change my configurations, this piece will stay in the same spot. Now it's important to note that if I haven't dimensioned the location of this circle and I change the configuration, it will not scale accordingly. It will not go to the center of the block. So we've seen something like this. Similar, what I need to do is go into my sketch and then provide some sort of indication that this circle is always to be in the center of this square. So I would probably do that with a simple line tool and the construction line type. I can click on the center of the circle and make it the midpoint of one side, the top or bottom, and then the midpoint of the left or right. So now all I need to do is make sure that these two lines are horizontal and vertical, and that will force the circle to be in the center. So I'm going to click on one of the lines and press the horizontal vertical relation, and now do the same with the other. You can also see that, as it should be, now this sketch is fully constrained. And now if I were to change the configuration, the cylinder would scale accordingly to the center. So the general steps when you're using configurations and parametric design together are to create the parameters for any relevant dimensions or features. So these are going to be in that feature parameter window that we brought up. So this is anything that you might be changing frequently or prototyping, or any dimensions that you want to have a relationship or a function with respect to one another. We're going to use functions and parameters to assign the dimensions that we create to sketches and 3D tool operations. Then we're going to create a configuration table if we have configurations. We're going to select which dimensions and features should be configured. And this is going to be anything that will be different from configuration to configuration, whether that's the length of an extrusion, the number of holes in something, or the length or distance of a dimension. And then finally, we need to assign the appropriate values to the configured dimensions and the features. Some of these may be functions or relationships that lead back to our original parameters that we created. So we're going to look at an example that combines both configurations and parameters. Here's what we're going to be doing. We're going to be creating a plate with holes in it. The variable parameters that we're going to have, the things that we want to be able to change, are the number of holes in the plate and the length of the plate. The fixed parameters that we have are the width of the plate, which is going to be 5 millimeters, and the height of the plate. And then the specifications that we have are that there should be an equal distance between all holes, no matter what the length is or the number of holes. And we should be creating 4 configurations, one with 1 hole, 2 holes, 3 holes, and then 4 holes. One additional parameter that I'm actually going to add is that this would be the diameter. The hole diameter is going to be half of the height. So these are fixed parameters. This is a variable parameter, just like we saw in one of the earlier slides if we're looking at some sort of function between dimensions. Okay, so this is the sort of formula that we're going to use to create this part. I'm going to switch over to Fusion now, and we'll take a look at how to do that. So I'm here in Fusion. I have a new part. I've saved it, called it config. First thing I'm going to do is set up these parameters. So I have these two variable parameters here. I'm going to go to Modify, Change Parameters. I'm going to create a user parameter called Number of Holes. This is going to be unitless, and we will start with 3. Or no, we'll start with 1. Okay. Next, I need the length of the plate. We're going to call this length. This is going to be in millimeters, and we will start with, let's start with 50 millimeters. Okay, so we have those. Now we want to look at some of these fixed parameters here, and these we're going to create both on the part, but we could also just type these in. So if I want, I can also create the width. This is going to be 5 millimeters. The height, is 10. And finally, the hole diameter is going to be 1/2 times the height. So here I've set up all my parameters. Now what I'm going to do is design the first plate and then create the configurations for all the other plates. So back in Fusion, I'm going to press OK on my parameter window. Go to Create Sketch. I'll make it on the top again. Making my rectangle tool. I'm going to dimension the length. And the width of the plate. That's set. Now I'm going to extrude to the height. Okay, I've got a fully constrained sketch. I've got my plate here. The next thing that I'm going to do is create a sketch on the face that is the hole. I'm going to extrude cut a hole through the plate. And then I'm going to use rectangular pattern to pattern the number of those cuts that I want based on the number of holes in the specific configuration. So first thing I'll do, create a sketch on this face. I'm going to create a circle. For the dimension or the diameter, I know this is going to be hole diameter. Then we also want this to be strictly halfway on the plate, so I'm going to, you could create a point, maybe I'll do that this time. I'll create a point here. That's the midpoint. And then I'm going to say that the midpoint that I just created and the center of the circle are always horizontal. Okay, now we need a little bit of math to figure out where to put this first circle. If we look back at our visual, if we want an equal spacing between holes, we can see that based on the number of holes, we're going to be able to identify the dimension between each hole and between the edges. So for 4 holes, the distance between each hole is 1/5 of the length. So 1, 2, 3, 4, 5. For the 3-hole version, the distance between each hole is 1, 2, 3, 4, is 1/4 of the length. So what this means is that our distance between holes is going to be, and I'm typing down here now, distance is going to be the length of our plate divided by the number of holes that we have plus 1. And that's because here we have 4 holes. The length or the distance between each hole is the total length divided by 5. So 4 holes plus 1 is 5. And here we have 3 holes. We need 1/4 of the total length. So 3 holes plus 1 is 4, and we get 1/4 of the length for the distance. So we're going to go back to Fusion now. I need to set the dimension between my edge and my first hole. And so this is going to be length divided by the number of holes plus 1. And so what just happened is we have a 50 millimeter length plate. We have one hole. And so our equation here becomes number of holes is 1, 1 plus 1 is 2. The length divided by 2 then puts this hole exactly in the center between the two edges of the plate. Okay, at this point I'm going to extrude. For the operation type, I'm going to use cut. And for the extent, I'll go through all. It's going the wrong direction, so I need to switch directions. So this is just saying that whatever hole I've created here, it's going to go all the way through. And if I were to now change the length of the plate, trying to make sure that you can see it here. The hole should stay centered. Similarly, for the diameter of the hole, if I change the height, it should scale as well. I'll set these back to 10 and 50. So now we're going to get into the configurations, and we know that between different configurations I need a different number of holes across here. So to make this a little easier on myself, I'm first going to create the configurations, and then I'll go through and add in the repetition of the hole. So I'm going to open configuration table. We need 4 configurations. You can name these as well. Okay, now we're going to create our rectangular pattern. This is going to be a feature pattern because we're featuring the hole cut. The objects, we can go down to the design history and click on Extrude To. The axes is going to be, in this case, the x-axis. For distribution, we're going to put spacing. And now we have our options here. So along the first axis, which is my x direction, I'm going to mess with this in a second. For the second axis, I only want 1. I don't want any additional holes upward. Okay. For the second axis here in the quantity, for the first axis in the quantity, I'm going to put number of holes. And for distance between each hole, I'm going to have that distance formula that I calculated here. So that is going to be the length divided by the number of holes plus 1. Oops, go back to edit. Okay, and we only want this in one direction. We don't want it symmetric. Distribution is spacing. And here we could configure these features. I'm going to do this a different way, but you could do this in the Edit Rectangular Pattern button. Okay, so I've got my 4 configurations. I've got the pattern created. And now what I want to do for each one of these configurations, I want to change my number of holes parameter. So if I am not in configuration mode, I want to go there. I can add aspects or hit the configure button. And now I want to go to my Add Parameters button. And we can see that here now there is a checkbox for whether or not to configure each one of these parameters. So what I know is that I want the number of holes to differ across my configurations. So I'll click that checkbox and press OK. And now in the column for number of holes, I want to set the correct number of holes. And so you can see down here it auto-updated for the fourth one. If I go between these different holes, these different configurations, the number of holes will change and the spacing between them will change. So this is very helpful if you have multiple variations of a part or different parts that are quite similar but have a slightly different feature or component for one of the configurations. And then in my parameters table, I could set things like the length. So if I change the length here to 25, it will automatically update all of those configurations and relationships that we've created. You can see for the 4 holes it gets a little too close. But that is the general idea, and that's how you can approach a design that has both multiple configurations and parameters with relationships between them. Okay, next we're going to look at freeform modeling. So what are forms? A form in Fusion, it's a mathematical model that defines a freeform surface. And so this is a modeling technique that's a little different than our traditional sketch and extrusion or sketch and revolve. We have now these surfaces that we create, and the surfaces, each one of these surfaces is defined by an equation, much like you might have a surface for some sort of three-dimensional relationship with XYZ coordinates and something like a saddle or a different hyperplane that represents an equation. So really these are just planes in three-dimensional space represented by equations. In Fusion, we'll access the freeform modeling by going to the Form tab. And in the Form tab, we have the Form toolbar. So here we have sort of these different operations that we can use. We still have the sketch feature, but now we have what are called these form creations, as opposed to our 3D modeling tools that we looked at in the earlier video lecture. It's very important when you're working with forms to save often. And once you're done exiting a form, it may no longer be modifiable in the form context. So if you've taken a form and edited it and moved around the surface, once you exit, you might not be able to go back and change it. So it's just very important to save often and make sure that you have everything well defined when you're creating a form. So we're going to look at an example of this in Fusion. We are going to create this kettlebell using this two-dimensional image as our template. And so the first thing we're going to do, we're going to open Fusion. We're going to create a form by going to the canvas and inserting this picture. And then we're going to use the various freeform modeling tools to create the three-dimensional object from this two-dimensional view. Okay, so I'm in Fusion. I've saved a new document, a blank document, as kettlebell. I did change the units to inches to reflect what is in the guide here. So what we're going to do is place this image down with the canvas tool. And then once we place the image down, we can scale and flip as needed. And you'll see why that's necessary in a second here. So in my workspace, I'm going to go to Canvas. I have this image of a kettlebell on my computer. I have the image selected. Now it wants me to select a face to put this canvas on. I'll select the front face. And you can see that my image is flipped. So when viewing from the front, the text is backwards. When viewing from the back, it's the correct way. It's not a huge issue, but for me, I want the text to be facing the front in my model. So I'm going to horizontally flip the image. And now when I view from the front, the text is the correct way. I can move around the image with these distance features, and I can also scale the image and change the opacity so that when I'm modeling I can see it better. So when we're looking at this kettlebell, we can see that there's two primary shapes or forms that we can create. The first is sort of a sphere, and in Fusion this is going to be represented by a quad ball. The other looks more like a rod or a pipe that is bent, and in Fusion we have a form of a pipe. So our general approach here is going to be taking an object, identifying the base forms that we can use to create that object, and then we'll refine the resolution, add fillets, those sort of things as we move forward. So first we're going to create the quad ball. I'm going to go into Fusion now to show you how to do that. If at any point the canvas is in your way and you don't want to see it, you can hide and show the canvases in the folder on the side here, much like you can hide a sketch. Okay. I'm now going to go to the Surface tab, Create Form, and I'm going to see the form options here. I'm going to do that again. I'm going to go to the Surface tab, Create Form, and I get the form options. So the first thing that I'm going to add in is this quad ball. I can select a surface to add this to. I'm going to click on the front. And then it wants me to have a center point, so I'm going to put this roughly in the center of the dumbbell. So you can see now I've selected that front face, so that's where the plane that my center point is going to be on, and now I can scale the quad ball to the correct size. So this is going to be approximate. We don't actually know the size of the quad ball in terms of the diameter, but we can try to get close. I would say that's about right. And if we move, we can move the quad ball now to line up with the outside edge a little better. And so to do that, once I have this quad ball inserted, I can go to the Edit Form tool. I'm going to select the entire quad ball, and I can move it a specified amount. So in the numerical inputs, I can slightly change the distance to move this. Let's say that looks fairly accurate. Okay. So now we're pretty much centered on the kettlebell. And I can hide the body and also hide the canvas if I want to make sure that it lines up well. So now I have this quad ball, but you'll notice the bottom of the quad ball is flat, and that's so that it rests on the ground nicely. So we'll want to edit this form here to make the bottom flat. So an easy way to do that is to go to Modify and Edit Form, just like we were. But this time, instead of moving the entire quad ball, we're going to take one point or one vertice of the surface and move that upward. And what it's going to do is pull the rest of these faces up and flatten the bottom. So I'm going to go to Modify. For my entity of the T-spline, I can click on edges, faces, but also points. So I'm going to click on this very bottom point. And then I can either drag or, again, in numerical inputs, enter a value. So this doesn't need to be super exact, but I'm going to start dragging this up until it's roughly flat on the bottom. And you can see that I'm a little bit off now in my total height of the ball, but that is where later on you can go back and sort of tweak things and modify things to make it more accurate. But for right now, I just want to show you how you can change a single point on the T-spline. And so now if we hide the canvas, you can see that the kettlebell is fairly flat on the bottom. The next thing we're going to do is create the handle. So for the handle, we are going to use the pipe feature for the forms. And for the pipe feature, you need a path to basically create the pipe along. So this is very similar to the sweep operation for 3D modeling. So what I'm going to do in Fusion is I'm going to show the canvas. I'm going to create a sketch on this front plane. And then I'm going to try to model this center line of this handle as best I can with the spline tool. And as it says in the instructions here, it's optional to use a mirror. I would recommend it because that way it's going to be symmetric and you're not going to have a lopsided handle. So for the spline tool, I'm going to click this first point and slowly click on points that are approximately in the center of the handle. Okay. Now, one thing I'm going to do is center this point with the center of my quad ball. As close as I can. I'm a little bit off-centered here, but that's fine for right now. Okay, so I have my spline. At this point, if I wanted to, I could mirror the spline, so I'm going to create a simple line construction, and then I can use this line to create the mirror. So in my mirror sketch tool, I'm going to highlight everything that I want mirrored, and then for my mirror line, I select that line. You can see here I only grabbed the points, so we're going to go back, get the entire list, and then just make sure we don't have the mirror line selected. There we go. Okay, so that grabbed all of the points on the spline for us. At the top here, there was a little bit of curvature at the end. So if I wanted to, I could go back and adjust that, but I'm not really too concerned about it. Okay, so now I have my spline. Now I can create the pipe form. And so here it's going to have me select a path. And you can see that that is a very odd looking pipe. What I'm going to set now is the global diameter. So this is going to get me as close as I can to the diameter of this handle, which obviously this needs to be much, much less. 0.1, that was actually pretty close. Yeah, I think I'm going to stick with 0.1. And right now it's very blocky. So there's a couple things we can do to change this. The first would be to change the display mode. So I can press on smooth, and it's going to smoothen the display of that T-spline. And here maybe at this point I want to make it a little larger. That looks pretty good though. And I can also go to my segments and change the density or how many segments there are. So this will improve the resolution of the pipe. The fewer I have, the less accurate it's going to be. press OK, and now we have our two features. We have the pipe and we have the quad ball. So here is the walkthrough visual for what I just did. I modified, created a pipe, selected the center line, and then went through and changed the display mode and edited the, under segments, I edited the number of segments as well. And so now what we're going to do is save the form, and then we just want to make sure that we might not be able to make any more modifications to this form afterwards. So make sure that all of your form creation and modifications are done before you save and finish the form. And so you can see right now I'm still in this form window, and just like I have a sketch window, I can select finish form here to exit the form. So I'm pretty satisfied with this. I'm going to finish, and now we have our form in our general window. And I'm going to hide the canvas so that we can get a better look at it. Okay, now we need to create a solid from that form. So the forms are just, remember, those T-spline surface representations. What we need now is to go into Fusion and create a three-dimensional solid body from the form. Okay, so I'm here in Fusion. I currently have the solid body that is the quad ball, and then this surface body that is the pipe. So what I need to do is combine both of these into a single solid body. If I go to create, I can do a boundary fill. And this is going to allow me to select both of these bodies. For the cells, I'm just going to drag and select all of them. If you are looking at creating specific bodies from individual cells within these surfaces, you can select those independently. However, we're going to put everything together all at once right now. And then for the operation, we want to join these two together. And so if I press OK, now I have a single body that includes both the handle and the quad ball. And so at this point, I can do some modeling features. So to get this final result, you can use construction geometry, such as creating planes and then making cuts. You can also add fillets in and add text and extrusions here, just like you would in any other 3D modeling case. So I'll show you really quick. You could add fillets in my solid 3D modeling tab, and I can select those connection points. And I could also go through and create some sort of offset plane where I can cut the surface. So I've created this offset plane. I'm going to make a simple sketch in this plane, make a very big circle, and you can see the plane bisects the kettlebell here. So all I'm going to do at this point, I've created a giant circle. I'm just going to extrude this entire circle outward and make sure that it's a cut. And so in doing that, I've created a flat face. And now on this face, I could add a text option. I can look back at my canvas and make sure that I get the correct looking font and add this bar here. And so I've done this already in a different file. But you can see how you could extrude and add some more fillets here. And we can get fairly close to the final kettlebell. So to summarize these freeform design steps, you can use the canvas tool to add in reference images, estimate the tools that you will need to create the design. For us, that was a quad ball and a pipe. Use each tool to create a form shape so we can select and move specific points, lines, and surfaces to achieve the shape we want. This is sort of a sculpting technique. And repeat until we have all of the shapes have been added and formed. We're going to finish the form, so that's going to be that checkbox in the top right, just like in finishing a sketch, and then connect the form bodies, in our case using the boundary fill tool here. And then finally, once we have those solid bodies, we can use 3D modeling tools like the plane, extrusion cuts, and fillets to clean up the design and make it more accurate. So in Workshop 5, you're going to be doing similar things that we did in this video lecture. So your 3 objectives, the first is that you're going to create a component that utilizes parametric relations and dimensions. You're then going to create a second component that has at least 3 configurations with different dimensions. And finally, you're going to create a freeform design of an appropriate object. So this would be any object that would actually benefit from freeform design. Clearly, something like a ball or a singular rod would not need freeform design. The specific deliverables that you're going to want to make sure are on 3 separate design files present in your Fusion folder. The first is a design file of a custom parametric model with variable parameters and at least 1 function dimension. So what this could look like is something like our ring, where we have a value that we put in, some sort of parameter, and then a specific function that references that parameter, that as we scale the parameter, it will scale the dimension that is referencing that parameter, just like we did with the ring and just like we did with the smaller simple box and the height of the box. The second file that you want is a custom model with at least 3 different configurations. So this could be something a little more advanced like we did with the holes and the spacing, or just a simple design that has multiple configurations. Could be something like different lengths in a certain dimension. And then the final file is going to be a custom freeform model, so you can grab an image from a website or take your own image and create a freeform model using the techniques that we learned here. So you'll need 3 design files. In this case, if I were to turn things in, I could turn in this ring file here, the kettlebell file, and the config file. Okay, so that was video lecture number 5. Next up, we're going to have simulations and generative design. And then finally, we'll end with design for manufacturing.